Awesome. Well, thank you everybody for coming at 8 a.m. For all the engineers in the room, I apologize as well. It's very early, especially to kind of kick off things. But I'm Scott Haynes. I've been part of the Spark and Delta Lake community for about like 10 years. Wrote a book, did a bunch of other cool stuff. And this is the second kind of series in like the Hitchhiker's Guide to Delta Lake Streaming. We're just actually now adding like tool calling and some other stuff to it. So I'll just kind of get started. A little bit, I'm like, I can't talk, it's 8 in the morning. A little bit about me. I'm Scott Haynes, I'm a distinguished software engineer at Nike. I've got a colleague over there, Bridger, what's up, dude? And I just enjoy teaching, mentoring. A lot of the things that people do is like they get later on in their careers, just teaching people who can still handle a full workday to get their job done very well. And I've also just been working on like huge distributed systems since about 2008. All right, so into what the session is. Does anybody here write anything on Kubernetes? All right, awesome. We got a couple people over there. There's something called crossplane, and it's all about like compositions. Compositions essentially allow you to create applications that can be essentially built via just configuration. So we're going to walk through an entire application that is configuration-based, and then we're going to walk through an entire application that is agentically generated, and kind of try and find like the connections and corollaries between the two. All right. Cool. That actually animated, which is nice. All right, so starting off, we're just going to talk about how do you create a generic application? What does that mean? And what does it kind of mean to build things based on components versus just building things as like a stream of consciousness in a notebook? So in a nutshell, anybody who's written a streaming application before has probably seen something very similar to this. Who here still writes Spark applications? Awesome, good. So these classes will make some sense to you as well. So with any kind of streaming application, you have a source. That source, in this case, we're going to just be talking about Delta Lake, but it can be anything that can be connected to a data stream. So we have data stream reader. That's great. That gives us bytes, creates data frames. We've got transformations. We've got a data stream reader. And essentially, if you think about like a REPL, we're essentially going through, we're reading, we're evaluating, we're printing, we're looping back again. And this goes on forever. The interesting thing about all of this is that almost every application you see is essentially just a UDF. So you can create components that make it really easy to create config-driven pipelines. And so the only thing you have to really worry about is how do I create transforms? And transforms are pretty easy as long as you understand the schema of what it is that you're actually trying to read. And so along those lines, like if you've ever called a transform function on a data frame, it's also chainable. And so there's a lot of things you can do just by doing a chain of transformations, but you don't have to really worry about what's coming from upstream or where is it actually going if that's all config-driven. You don't have to even really worry about it too much. And that's kind of where a lot of these like base application patterns come from. This is essentially like the foundation of how you build like an agentic pipeline. So moving over there. So everything just kind of depends on like the state of the application. So if you're just reading and writing, then like you're essentially just having like an extract load pipeline. And so like you're missing like the T or the small t. And some people just kind of call that small t as well. Going back to the base applications. If anyone's ever written applications in a shared environment and had anybody else rewrite or overwrite checkpoints, it can be painful. If you've ever written an application, you've accidentally blown away your checkpoints, it can be painful. There's a lot of things you can do to actually optimize the way that you write your checkpoints. And so in this application over here, for brevity, can't really see it on the bottom because like we have the subtitles, but my footnote says pass is just basically used to be able to put this all on a slide without having like an entire class. So at Nike, we worked on something called Picasso, which is essentially a way of creating generic pipelines. And so those are all based on like streaming applications that took essentially like Spark configuration to go auto-wire themselves. So if you're like familiar with like Drop Wizard, Spring, anything else like that, that's sort of the same idea where you're just auto-wiring applications, all based on configuration. So what changes the least is a lot of times configuration. What's most important a lot of times is configuration versus like magic numbers and things like that. So everything starts off with a streaming app. So if I have a streaming app, I don't know if you can see this in the back. I chose green, which is probably a bad idea. But essentially, if we're reusing any kind of like Spark application config, so I'll have like Spark app name, Delta to Delta app, Spark app version, so I can keep track of things for monitoring. If I want to take a look at a new checkpoint path and I'm using Unity Catalog, I can create a Unity Catalog volume to put all of my actual checkpoint data in. So as my application is streaming, if I have any kind of stateful operations or transforms or anything else like that, I can always get back to exactly where I was before. And then the interesting thing too is that a lot of times, like when you're running a streaming application, whether it's Delta Lake or anything else, you also have a checkpoint version. And so if you want to blow away a checkpoint version because you're doing a triage job, you might want to split it at a certain point in time, copy everything from a volume, and start in two directions. And there's a lot of different things you can do with that as well. So being able to have everything be config-driven means that when you get paged at 3 in the morning, you can basically just go bump a version number, start a job to go do like a triage, and then everything else can keep on running without you having to think about it. Agents are also good for that. So in this case, we've got a streaming app, which is like the base of our application. These are just kind of first principles. A streaming app needs to create we need to generate a stream. So what exactly is that? We're reading stream with options, then we're gonna do something with that. It needs a format. So if you've ever used Spark before, you've got a read stream, it's got a format for Delta, now we're reading from Delta, that's awesome. If we wanna write to Delta, we're using Delta format again, it's pretty easy. So it's all part of like the kind of boring boilerplate. So source components, right? I don't know if you can see this from the back. I'll post the actual slides after, but in this case, we've got a source generator. It's got a config prefix, because this is a config-driven application. It's got a table, because it's associated with an actual upstream Delta Lake table. We want to go generate some options. We want to go essentially be able to auto-wire this just based off of configuration. And then at the end, I also want to be able to go create a data stream reader. So for the data stream reader class, it's essentially what you can actually composite. So it doesn't do anything until you actually call load or you call .table on it. At that point, you have a data frame that's a streaming data frame. But before that, you have a promise of something. So we like promises of something, because it allows us to do something different with it if we want to. So in this case, under generate, I think there's a pointer. Hold on. I'm looking at, probably no one can see the red, but over here, it's like self app, generate read stream, generate options, format Delta. This little block right here, cool. Now we're going to create a streaming application that is a Delta-based application. So going back to the actual presentation, we're creating Delta Streamer. We are doing Delta streaming. Sorry, it's 8 o'clock. Cool. So other than that, just kind of piggybacking off of like kind of common things that people see in Spark applications, like 2 data frame. Yay. All right. So right now we have a base application. The base application gives us our configuration. It also gives us our Spark session, allows us to piggyback off of that to do interesting things. It also gives us an interface to go and generate streaming sources. It gives us an interface for creating streaming syncs as well. There's also streaming options. So I helped write the Delta Lake Definitive Guide. It's free if you don't want to pay O'Reilly a lot of money for it. If you just go to delta.io, you can download the PDF for free. So we go over essentially like all the options that are available for like what's the streaming source? What can it do? What does all this actually mean? Like if you try and encapsulate like an entire book in a session, usually you run out of time. So some of the things that are most interesting, like for any kind of streaming application, is essentially rate limiting. It's like how fast do I run out of memory or how fast do I not run out of memory? So there's also like runtime ignorance. So if I'm running a job and I don't care about changes, I don't care about deletes, I can keep my job running, essentially not ever worrying about what's actually happening upstream until I hit like a schema change that breaks my application. And so being able to do that allows your applications to continuously run. 2 years ago, I gave the same session, which is just the Hitchhiker's Guide to Delta Lake Streaming. It's all the same Jupyter notebooks that are used for this session as well. And that goes through everything you'd ever want to do with Delta Lake Streaming prior to like the agentic world we live in right now. Cool. So far, any other kind of questions at this point? Perfect. That's great. All right, so Delta Lake, if you've ever used it, same as Iceberg, you have the ability to time travel. You can go back in time. You can go back to an earlier version of your application. For people who've been doing data engineering for a long time, triage is difficult. But if you can just roll back to a specific version, that's really great. And it's another thing, too, where if you want to outsource the ability to go and find the last good state, last good version of like an application, It's another thing that is very good for like an agentic flow. It's like, go find me my last safe state, take me back to it. All right, so moving on from there. So engineers in general are lazy. Because we're lazy, we like to do things where maybe we'll take a lot more time to go and actually build something that will then help us be even lazier in the future. So we spend a lot of time being extra lazy, which is kind of a weird thing. So if I have a source generator, I've got a config prefix. This is essentially just the implementation of like my source generator. So it takes options, it rolls those options up into an actual class, and that class has a bunch of different capabilities as well. So we want to do as little as possible. We want to remove as much human error as possible as well, and we also want to be able to have interesting defaults. So I don't have defaults right over here, but anything that would be applied as a source option for your streaming pipeline that is common in most cases would go into my option defaults. Anything else would just be overridden, and then just get merged together. And so we can take a look at that stuff as well. So down over here, I'm not providing like these functions, but generate options dictionary, I'm taking my config prefix, which is like Spark app source delta, taking my options defaults, and then I'm mixing in what I have actually on the Spark session as well. So then we're just doing like a merge override for that. All right, so that's pretty easy so far. As I said, it's basically boilerplate. Do as little as possible, and then go create cool things. So your application, like as boring as this actually looks, is essentially just a series of different configurations, and then you just apply transformations. So I've got a source, it's Delta, it's got a table that has a catalog. That table has a schema, that table has a name, awesome. If I want to keep my state around, I need a checkpoint path. Awesome, that's great. I have a sync that's Delta that has a catalog, a schema, and a name. This stuff's not very difficult. It's essentially just us keeping track of these variables in a safe spot so that we can do an application release and go on with our lives. So the big important part, right, goes back to still just the transformations themselves. So again, we'll save questions for the end. Okay, so the big thing over here, so I want to transform my source, and then I can transform and do as many things as I want. So leave this up to your imagination. Everybody's project is different. Every transformation that we're doing is different based on the goals of our applications. So that's awesome. So focus on what's important. I don't know if the pointer is showing up, but on the bottom, focus on what you're doing and what you want to do versus just wiring up an application, because that's the most boring part of your entire job. All right, cool. So we're going to finish up the writer now. So this is the other side of the other boilerplate. So far, from my diagram, we've gone through the source. We've gone through the streaming reader. We've then applied pretend transformations. That could be any transformation you actually want to bring to the table. It could be UDF, it could be a SQL expression. That doesn't really matter. At the end of the day, your write stream also takes options. Those options can be configured as well, and that allows you to control your application without having to really do any real manual work. So in the same way that you don't use magic numbers in your applications when you're writing like actual source-controlled software, the same thing over here can be controlled through just configuration. So config-driven development sounds boring, but it takes away a lot of the heartache of when things go wrong. So this probably doesn't read well from the back, but if I have a data stream writer and I want to actually write that data stream out, in this case I want to go create a stream that's writing to a Delta table, I pretty much need everything that I talked about before for the other kind of boring side of the application. So up in the top, you can't probably see it underneath like this cool, I don't know, curtain. But we've got a streaming app, which goes back to like our application context. We've got a streaming prefix, so Spark app sync Delta. We've got a table name that we're going to generate based off of like what we actually have in our session. And then we're going to read a data frame in either at the time of our class generation, or we're going to go do it when we have a couple of these different functions over here. So we've got a from data frame. So in a lot of cases, you'll see to data frame. So from data frame just absorbs a data frame and then creates a streaming pipeline, which is kind of a fun practice. So it's kind of self-explanatory. It takes a checkpoint location so we can save our state, and then that saves to whatever checkpoint path you have, be it a volume or be it like an S3 bucket, et cetera. So from data frame, awesome. We're going to go read it. We're going to take it from the application, and we're going to crash. That's essentially the only options we have. Then the really only important part over here that matters is I'm going to go create a data stream writer that has an app. I'm going to generate this write stream. I'm going to generate my options. I'm not thinking about any of this stuff. All the stuff is kind of self-explanatory, and it's config-driven as well. So the other interesting thing over here is like, if you think about like what it is that a streaming application does, it either goes as fast as it can, it goes and operates once with a trigger, or it operates many times with a trigger until we run out of data. So you've got like available now processing for triggers. There's a lot of different fun options. And so if those are also configurations, then you don't have to think about setting that. So if you have an application that you want to run as fast as possible because you're trying to catch up, you can do that. If you want to slow it down, you can do that all through the configuration. And again, it's kind of boring. You're just like, you're moving knobs around. But functions auto trigger, functions auto partition, cluster by, also just takes configuration as well to apply to the actual end pipeline. And this is all still boilerplate. So again, focusing on transformations is the only thing that actually is important because everything else is boilerplate. So kind of in conclusion, like data sources can be configured in a generic way. It's not super exciting at like 8:18 in the morning to think of the fact that we're looking at boilerplate and we're looking at configuration. But it's really interesting if you have to create a bunch of pipelines and you're doing all the same thing over and over and over again to be able to just configure all of that to just be something that essentially runs itself. And then like your applications themselves essentially look like this, right? I've got an app, I've got a streaming data frame, I'm going to transform it and do something with it. Then I've got a streaming query that I'm going to run. In this case, I'm calling to table, which means it's going to write out to a managed table in like Unity Catalog. Then anything outside of here can sit there and basically run. We're going to wait termination until our stream dies. We can inject monitoring and anything else using Spark Streams to be able to get into like the other streaming queries like within our application as well. All right, let's see if this one works. Cool, never mind, I thought it was on a different slide. All right, so assembling the pieces, right? So what we looked at so far was how to build an application that's essentially just a composite of configuration so that you focus on transformations. Being that transformations are fairly simple for an agent to figure out, then you're kind of outsourcing most of the work to either configuration and guardrails or to an agent that can go and then do your work for you. I think about that as like an agent that's doing my work for me. So Scott 2.0, whatever else we actually want to call it. So agents help us along our way. And so what we're going to look at for like the use case is essentially like assisting us to find important information about our tables. And then this other stuff is more kind of food for thought. So if you have an agent that knows a lot about the context of your tables, your application, anything else, you can generate clean test data, which allows you to do stuff where you're not just reading prod data back into your actual applications. Figuring out the right syntax for specific things without having to look it up. If you want to do lateral joins, ask it to do it for you, and that's great. And there's just so much more. All right, so with that said, for anybody who's older like I am, we have this wonderful game called Zelda. In the very beginning, you get a sword. In this case, we're getting Delta, just because the conversation's on Delta. This could be an OpenAI logo. This could be Anthropic's logo. This could be Iceberg's logo. It doesn't really matter. But you're getting something that's going to help you along your way, right? So cool. Thanks, PowerPoint. It's a nice one. All right, so workflow automation with agents. So this part's also fun. The last part was kind of fun, but it's more boilerplate, so it's kind of boring. So who's written an agentic tool? All right, awesome. Got a few people in here. We're going to go through what tools are, how to use tools, then how to incorporate tools. There's also going to be like a gigantic bit.ly. So if you want to go take a look at like the Jupyter Notebook versus taking a look at my really crappy slides, you can actually scroll through like on GitHub, and it renders really nicely as well. All right, so moving on. Last time I did this whole entire talk, there's a lot more references to the actual Hitchhiker's Guide to the Galaxy. This time there's essentially just one real reference to the Hitchhiker's Guide to the Galaxy. So does anybody know the answer to this? All right, awesome, cool. So it's tools and the number 42. Woo, good joke. All right, awesome. So moving on. I spent way longer than I wanted to trying to find a schematic of a watch. I used Midjourney for like 3 hours trying to get like a cross section. I wanted to see like exploding gears, and it didn't work as I wanted to. But I did find this kind of interesting, picture. I think of a Rolex, right? And so the interesting thing is that if you think about like an agentic tool, in the same way that you think about a watch, you can think about a tool as like essentially like a component. And so, is it a gear? Is it a screw? What is it doing, right? It's essentially an atomic unit that does something. But it doesn't really matter on its own. It only matters when it's all assembled together. And so if we think about that, right, there's a reason for all of this. Like, our LLMs are incredibly smart. So I have this little kind of quote that I came up with. LLMs know a ton, but sometimes they struggle to distinguish between a ton as being a unit of measurement or a ton as an expression. So it's like, I had a ton of fun. It's like, oh, cool, you were weighed down. It's like, that's not correct. And so context is always king when you're trying to create essentially yourself, or a better version of yourself that can do work while you're in meetings or something else like that as well. So context essentially it's providing a guiding light to a system that doesn't really see. Like, it can see, but it's just not seeing the same way that we are. And so we have to kind of lead it along its way. So LLMs understand language and patterns really well, so we must just act on the part of providing essentially memory to that system. So I think most people in here are data engineers, or they're like within kind of the data engineering track within the companies that they work for. I am as well. The interesting thing is that a lot of data engineers also came from like a software engineering background. Tools, tool calling, everything else is essentially just APIs. We're creating APIs that are very well described so that we can create a system that understands and recognizes what it is that we're trying to accomplish. And so we're going to take a look at that right now. So, hold on, I'm going to have this disgusting rock star. Hold on one second. Oh, gross. Okay. All right, so LangGraph 101. Has anyone heard of LangChain? Awesome. So LangGraph is part of LangChain. I think it's like now the superset of like a lot of like the base tooling that came from just original LangChain makes it easier to kind of keep track of memory. Memory and agentic systems are essentially the way that you keep track of short and long-term things. If you think about the conversation we've been having, we went through this entire session so far. We're about 24 minutes into it. In that 24 minutes, we've talked about building applications. Many people probably forgot what the first slides are. It doesn't matter. And it's the same way when you think about like an LLM and how it's actually thinking and working with us. Things only matter for a few kind of like epochs back. So if you think about this essentially as like a sliding window of memory, memory in an LLM for your actual session is essentially just being tracked via tokens. So I have a certain number of tokens before I'm going to start forgetting, which is kind of the same thing we do. We get caffeine, we get something else, we boost our tokens, our life goes on. So anyways, what is a tool, right? A tool is essentially an API or a function. And it really kind of depends also on whether or not we are embedding a tool or if we're using a remote tool. So people have probably heard of MCP, like Model Context Protocol. That's just a remote way of doing essentially the same thing as having like a local API. But also, in this example, I'm using the Databricks like Workspace SDK. So that's already my SDK, it's already my API. This stuff is pretty much interchangeable at this point. So what are we actually doing here? Does anybody use Unity Catalog? Awesome. So I don't have to explain Unity Catalog, which is great. So Unity Catalog has a bunch of different catalogs. Your catalogs are essentially context for schemas. Your schemas are now essentially a more bound context for a collection of tables, volumes, models, everything else, and that just kind of keeps on growing. So for now, we're just going to think about that as a series of tables, right? But we have this hierarchy. And that hierarchy is also good for memory because I don't have to think about everything. I can contextually only keep track of the last few things that I'm thinking about. And so in kind of having the conversation about tools and tool calling, this felt like an appropriate analogy as we started going through building up a system that understands and recognizes context and hierarchy. So tools just require a lot of descriptive metadata. If you've written like Swagger APIs or any other APIs in general, if you want someone to use it, you have to document it. That allows them to use it without actually creating a meeting. If you work at a big company, you'll have a lot of meetings. It's hard to get your job done if you're always in meetings. So if people don't have to ask every time they want to use something, that's great. It's the same thing with an agent. if my agentic tool doesn't have to really describe a lot and continuously get things wrong, then the LLM is happy, I'm happy, and the cost for context doesn't go up too high. So if I want to talk about a catalog, right, all I have to do is basically describe it. So I don't know if people can see the red in the back. Maybe it doesn't show up, but so like with any API, we've got a request, we've got a response, and that's highly structured. And there's a really big reason for the structure itself. The structure allows us to tell our tool calling LLM what everything means. So if I've got a base model that's a list catalogs request, and I've got max results because I want to actually limit the number of results, then I can tell it it's the number of schemas to return from this request, which is a typo because I copied this yesterday from the schemas example. This is supposed to say catalogs, but that's okay because it doesn't really matter. So forget schemas, call it catalogs. So great. So we've got a field. My default is 1. I've got a description. I want things greater than 0. I want them less than 100. I've now told the LLM exactly what it can do to use this max results argument. I also have a response. That response just has a list of catalogs. These catalogs are just strings, but the description is the name of the base catalog. Yay, this is getting fun. Everyone's probably having a good time. Tool, list catalogs. Description, returns a list of base catalogs individually. I like to add more punctuation. It's fun. I think the LLM enjoys it as well. So individually, each catalog name can be used as the parent catalog reference for the schema or table discovery. These are all important things because essentially, like, if you think about, like, how did Google learn back in the day for SEO? It was through descriptive metadata. Our tools are essentially describing what they do using descriptive metadata. The one thing most people don't usually have in Unity Catalog is descriptive metadata. And so this is a really good forcing function to be like, if you want to automate your job or automate part of your job, then provide more descriptive metadata, and then it gets easier for you to automate your job. All right, so this is pretty much it, right? I've got a name of a tool, I've got a description, I've got a schema, because I don't want this to just be like random bytes, right? I want this to actually be a typed response that can then be parsed and read very easily by the LLM because it understands patterns very well. And we're returning this directly. Yay, that's awesome. So if I want to go list catalogs, right, we've done all the same thing over here. We've described what it is that we want to actually call on our list catalog, and we're taking a max results option. Option is 1, our default is 1. This is pretty basic stuff right here. So this one returns an iterator over here. When we call workspace client catalogs list, that used to be over here, so ignore this line. So we're limiting it to a max number of results. We're trying this, and if we fail, we're going to return a tool exception so that our agent actually knows that we failed the tool call versus us just being like, this was awesome, it worked out really well, and then kind of moving on. So it needs to understand what it is that occurred. Okay, so speeding up, let's automate a data pipeline. This part, if you want to go read along on your phone or anything else like that, hopefully this is big enough to kind of show up for the QR code. So let's leave it up for just a sec. And while I leave that up, we'll just talk about what it is that we are doing. So pointer, I don't know where that is. There it is, okay. So what did we need? We needed access to Unity Catalog. Cool, we got that. That's also part of our list catalogs request and response. So tools that do the following are what we need. So if people have ever worked with product managers tell people about what things should do. Engineers also come up with things to do. For us, we have to think about how is it that we explain to an entity, I'm just going to call it an entity because I don't know what else to call it, but how do I explain to a foundational model that I want it to do a series of things? I'm not going to tell it how to do a series of things. I'm just going to give it options to try and figure it out on its own. It's much more intuitive than we are, so you'd be like, here's all these cool APIs, and it's like, I got it. I found a cool way through this. And so for this example of creating like a typical data pipeline, usually you have a source. You know where your source exists, and you know the schema of your source and other kind of descriptive metadata. So you can then go and create transformations on that source data. You can join it with other things to accomplish other things. So you need a catalog. So we have list catalogs, check. We need to be able to list the schemas of a catalog, cool. We need to be able to list the tables of a schema in a catalog. I was very explicit over here where it's like we're essentially just kind of taking steps down a tree. And so everything that we're doing, we're providing essentially similar context and similar descriptive metadata I know it's boring. Like this is like, it's very basic stuff. But catalogs, schemas, tables. And then if I want to find out more about a table, I want to go get just a gigantic amount of detailed information. So I want to understand what are the table properties. I want to understand actual comments on columns. I want to understand what it is the table's purpose is. So if you think about like discovering things, our LLMs are discovering what it is that we intend to do with something based on the metadata that we provide. So if we don't provide anything in Unity Catalog, then we actually have to go and read the tables to summarize what it is that the table actually does, which is a lot more expensive than just using metadata to accomplish the same thing. So moving on. We're going to continue building up these tools. These are also part of like they are part of the Jupyter notebook. And they also work, which is cool. And I'll show a video at the very end as well. So we've got list schema request, all the same stuff. Name of the parent catalog, Unity catalog containing a schema, max results. The important thing with a lot of these is that because things are pattern matching, don't just keep on changing like the name of descriptions. If you're going to use like things like max results, continue to call it the same thing. Contextually, it's a lot easier for the LM to remember if it's exactly the same thing. It's going to control the same process. That's easy. So list schemas returns a list of schema names, if they exist, from the associated Unity catalog name. Takes a schema request. This stuff is all rinse and repeat. So again, most of the stuff that we do is boilerplate, and so we can automate a lot of our boilerplate by creating tools that then do those things for us as well. So schema takes a workplace client, schema list, great, catalog name, including this stuff. Yay, that's awesome. So we're going to go now return a response. This stuff's really, I'm just going to kind of power through this part. So list tables, same thing, right? What is it that we're doing? Well, for us to go and find a table in a catalog, we need a catalog name, we need a schema name, we also need max results again. We catalog, schema, table. Yay, all the same kind of basic stuff. Like if you think about it and you're creating a notebook or you're creating anything else, like you essentially go back to the same kind of 6 properties that we looked at when we were looking at like the generic compositable data application. We essentially just have a pointer to where data is, and then we have a pointer to where data is going, and that part's pretty basic. So yay, all this stuff. So workspace client, bunch of different options. This stuff's all very well documented, so I'm not going to go into it as well, but if you want to reduce the amount of data that comes back from the SDK, you can do that so you can essentially trim the amount of context that the LLM needs to retain in memory. And that's pretty much that. So these have been fairly simple up until now. Now we're introducing what no one can probably see in the back, so let's describe it. So we've got table column. I want to be able to describe to the LLM the notion of a column. Like, what is a column in a table? It understands it already, but I want to give it a little bit more metadata. So in this case, I have a column. It's got a name, which is a string. It's also got a SQL type so that I can be essentially type safe and think about what it is that, what it is that this column is. Is it just a string? Is it an integer? Is it a timestamp? Is it a timestamp with nanos? Like, there's a lot of different things that things can be. And so the more contextually relevant we are, the easier it is for our applications to write themselves. So I've got a table column with a bunch of information. I've got comments. Yay, is it nullable or not? So then we can say, I only want to take a look at fields that are, say you're creating a machine learning pipeline, anything else like that. I only care about, things that can't be nullable. That's awesome. We can read all that stuff from the table API as well. So table request, table response, all boilerplate, fun information about the columns, comments, everything else like that. Again, all we're doing is saying, how do I use this thing? What does it do? How does it represent something that I want from the machine? So tool get table details provides metadata about a table within Unity catalog. The details include table name, comment, description, columns, cluster, or partition information. Yeah, it's kind of like that sing along with the bouncing little thing. So get table details. All this stuff is pretty much rinse and repeat. We've seen this before. This is essentially the only kind of difficult function over here. So we're getting information about our table. We're bringing all sorts of metadata with us. This will come in about maybe like 2 megabytes for a table. So there's a ton of information, and you have to trim that information down. It all depends on how you're actually tuning your tools themselves. But in this case, we're finally using this column, table column over here. So we're saying I want to return table detail responses that has a full table name. It's got a comment on the table. Then for the columns, it takes the actual named table column. So type safety is great because type safety enables our tools to be able to have additional context within just like the response. So in a lot of cases, if you're just returning like a blob of text, there's no real kind of structure to it. And so again, LLMs enjoy pattern matching, and they enjoy structure. So the more structure we can provide, the better everything else is. Okay, fruits of our labor. All right, I'm almost done anyways. 3 minutes left. So this video is going to run for 2 minutes. So you're a senior principal engineer. You specialize in data-intensive applications and stream processing at scale. I don't know how to pause this. I'm going to go back for a sec. Hold on. First time doing the video versus just like failing at doing a live demo. So I didn't explain this part yet. So given that an LLM is essentially everything trained on everything, we need to be able to provide context to that LLM. So system prompt is essentially saying like, I want you to be this, right? If you've ever used like Midjourney or anything else like that, it's like, act like a graphic designer and go create me a logo like this. That's essentially setting the context so it has a subset of information that it actually can lean on. And so you're a senior principal engineer, you specialize in data-intensive applications and stream processing at scale. You prefer to have short conversations and your brief responses contain mostly code examples. Kind of like my slides, this is how I like to act. So I wanted to create something that acted a lot like me. So you're an expert in Python programming language, all code examples must utilize Python. Essentially all we're doing is like setting like some guardrails. Like if you just arbitrarily create a system prompt and say just do whatever you want to, a lot of times you'll get back Scala, you might get some Go code back. Spark has Go with Spark Connect, but I don't want to use Go for this application. And so you have to tell it exactly what you want it to do so that you can kind of bound everything in that conversation. So then there's me. So I'm like, hey, I'm Scott. I just joined the team. Can you help me find some tables to work with? And I'll play the video. Also, this is important too. So it takes 7 seconds to do all of this stuff, and it costs me less than a cent to run everything here. So I'll help you explore available tables. Let's start by checking what catalogs are available and how we can drill down into the schemas and tables. List catalogs, great. Max results 10, awesome, cool. The tool it found is list catalogs. That's not super difficult. It finds a development catalog and systems tables, awesome. So can you show me the first 20 schemas in the development catalog? It understands context from the last state. It goes, cool, that's interesting. So I'll list the schemas in the development catalog. Again, all it's doing is essentially adding arguments into functions, and it's getting results. So I want to list schemas. Here they are, development. We've got this behavior events. We've got the CDP experimentation, Nike team innovation, templates, a bunch of other stuff, and I also trimmed down a bunch of other things because this is from like Nike systems. So thank you. Using the same parent catalog, can you show me the first 10 tables under the consumer behavior events? Same parent catalog doesn't actually have a template variable, but it understands it contextually. So it says development, consumer behavior events, max results 10. Cool, I'm gonna go list those tables. So it figures out exactly what it needs to do, finds that I have one table over here, and that's awesome. So next I go, okay, cool, thank you. Always be kind, right? So using the same parent catalog and current schema, can you find more details about inspect table? If you've used Python and you forget an F, you'll get something like this versus an actual injected template variable. But don't worry, because it understands, it's like, oh, you left a placeholder. I'm like, oh, thank you for that. In your request, based on previous results, I can see there's only one table in the schema. Do you want to use it? Sure, let's do what you recommend. I don't want to do anything. So I'll get the details for this table from this catalog. Awesome, get table details. And over here, we just have that gigantic mess of data that I was talking about before. So trimming this context window is important because there is a lot of information that comes back. So if you give a ton of information to the LLM, and you don't trim it down, you're going to essentially run out of tokens, and it's going to lose memory, essentially potentially like halfway through the context of the conversation you're having. Luckily, in this case, it doesn't matter because it still works. So show me how to use that response as a streaming data source in PySpark. So this goes source table, I did it, consumer behavior, blah, blah, blah. I'm trying to keep up with the video, which is really hard. So it goes, it creates the checkpoint location, merges the schema, does all this other stuff, tells me other things that I can do, which is nice. Can we add simple transformations? I want to explicitly call out column names. So it knows column names because we created actual structured responses. So now I can go through and I can create all my column names. And the nice thing too is that it's going to also normalize anything that's actually nested as well. And I didn't have to say anything about that. And so that's essentially it. So create a couple tools, provide the tools to an LLM, and then start to automate your life. So closing thoughts for that. So data pipelines are not that hard to make, which we saw in the very beginning of the presentation. Using config-driven software development engineering design practice patterns takes us 90% of the way anyways. So then getting agentic assistance can be amazing if like what we're doing is essentially like automating like the tedium, right? It's like, I don't want to go into Unity Catalog and keep on thinking about this stuff, so just tell me what I should be doing with that. And then I'm going to go focus on transformations. So context is short, right? So memory is a tough nut to crack. Do you want to keep things in short-term memory, or do you want to actually start to put that into a vector database? There's a lot more conversations about this going on this week, so just keep that in mind for food for thought. So providing all the right tools can take a long time, especially when you're thinking about kind of what level, what hierarchy you want to work at. So the one thing that this didn't go into was like, if in the notebook environment, I start giving access to the tool to go write, I need to be able to say, what's my current working directory? How do I go and create a new directory? How do I go and like, essentially do other operations and actually run code on my behalf? If you've used Claude Code or anything else before, it will run things on your behalf. You'll say, go create a new branch from this repo and go do my work for me. It's not exactly that easy. Sometimes it can be, but when you're doing the tool calling yourself, it's a little bit more safe, right? Because you don't, in other cases, you don't know exactly how it's working. So if you have to work with like, corporate security or anything else like that, you can say, oh, but don't worry, this is all bound to the context of the Jupyter notebooks that are running inside my Docker container. It's using my bearer token to connect to Unity Catalog. It's using my permissions to go do all that work. That's an easier conversation to have. And then cheers. So long and thanks for all the fish. So thank you.